Hello, this talk is not about P4. I'm really sorry. It's about this old stuff called OpenFlow, and about a company that was so fed up in not getting a free operating system that we actually did it ourselves. Looking at what is required, so here I'm trying to present what you actually need if you want to build an open source router based on, and that of course is only Broadcom hardware for now, but there's nothing standing against doing anything else. But here I'm speaking about mostly Broadcom. So you have a couple of options. Typically, what you need is you need a routing engine, you need a whitebox switch with operating system, and then you need this glue in between that translates the outcome of the routing engine into the ASIC. That glue in between, first of all, is to a good part the operating system itself, and second, you will want to have some sort of an SDN controller, especially if you speak about, well, OpenFlow or OpenNSL or P4 runtime, GNMI, etc. So that's what you need. But then requirements are pretty much differing. Some people actually want all of that in one box and to behave like a real router, and I don't want to write any extra code, and I just want this thing to be working as a BGP router. Other people would like to have a scalable approach, so I actually want to have ONOS and multiple switches controlled by one controller. You may want to have the ability to modify code on the router if needed. You may want to fix bugs and add features. So there's a bit of a difference in requirements. We are concentrating here on the OF agent, OFDPA. That was an early design decision, which turned out to be maybe not the very best one. We should have gone for the proprietary network stack right away. That would have been a lot faster. Anyway, now we know. So, taking stock. Next slide is where are we with the operating system with the for the whitebox switches. There is of course Open Network Linux, which is great because it contains a lot of vendor extensions for fan LEDs, SFP recognition, all the ONLP stuff. So that is absolutely necessary, but it's inherently useless for the purpose of building a router because this glue is lacking that translates the output of the routing engine into so inherently useless, I said, unless you have those Debian packages that do the OF agent, OFDPA, OpenNSL, Saraf of ONF, put some of those 4 edge core switches up onto the Trellis Cord website, but only for very few switches. And apart from that, you're still on your own, or you have to go for commercial operating systems. So we did something that we had to call BICN Linux. We asked Linux Foundation, so how are we supposed to call this thing? And I said, well, the easiest thing is you go for BICN. Okay, so there's a name. It's same, but different. We started to build everything on Yocto because it's the standard build environment for embedded systems. It gives you regular updates, recipes for basically running building your own Linux distribution. We run on OFDPA 3.05 with quite a number of OFDPA fixes that we did ourselves, so I would say it's a bit more stable now. We tested it with Rio and ONOS, so it will also work in Trellis. And we added a handful of mostly Delta-based switches, but it's also running on EdgeCore, 1 Quanta, one Redstone. So this is more an exercise of how portable that is. Most of those switches are anyway very similar internally until you get to the point of actually talking to SFPs and fans and so where you need the ONLP stuff. SDN controllers, yes, there is ONOS and Open Daylight, there's Rio, but essentially, at least the first 2 are pretty bulky, if I may say that here, and you will never squeeze them on a switch. So that one requirement, I actually want to run this stuff on the switch itself. you will not do with ONOS or ODL. And it's already slightly hard to do it with Ryu, but it works. And the other problem is, especially when it's about actually building a router, stuff that is pretty common for the last 2-3 decades. You don't want to reinvent everything and rewrite every network application as an app on top of the controller. So you don't want to rewrite BGP, OSPF, etc. So what we did is we wrote our own controller, which is a C++-based netlink to OFDPA translator. Nothing particularly special in the idea. That dates also back like 9-10 years. I think Routeflow was the first concept that was translating, that was listening to netlink and translating the creation of IP addresses on ports, routes, VLANs, bridging entries, all of that into the ASIC. So this is the glue that we were missing between the routing engine and the ASIC. We're using OFDPA, and then we're having this relatively slim controller that integrates fully into Linux kernel. We needed to add a gRPC interface because there are certain things that you just cannot do with OpenFlow, so creation of VXLAN interfaces, certain statistics where you want to go beyond the limitations of OpenFlow, mirror port creation, certain things that you just want to have on the switch and you just don't get through OF. So we do an additional gRPC call down into OFDPA or into the SDK, and it's all on GitHub. That's the Basebox D controller on GitHub. The routing engine is FRR because there's a dead Quagga here. That's a nice, I took that picture myself. I really like it. This is how a Quagga looked until 1863. So now we have FRR, and you have options now. You can run this thing, you can run FRR on the box. It's talking to netlink. There's this Basebox D controller that speaks OpenFlow to the OF agent that configures your ASIC, and all of that in one box. That's on the left side. If you go to the middle, it's OpenFlow. You can pull it out. It's actually meant for being remotely controlled. So I can run on my laptop the Basebox D controller, and I all of a sudden have 54 ports, which are tap ports, but I can configure routes and interfaces and everything on my laptop, and it just behaves as the switch because it talks to the switch remotely. And then you can also have multiple switches controlled with something like ONOS. If you have any questions in between. So where are we really with this? It's been quite an effort, especially for a small company like us. There is layer 2, layer 3, V4, V6, VXLAN. You get for the off-switch operation, we have packages. So you have packages for Fedora, for CentOS, that you can just get and install in a VM. And you can then configure the switch to be, there's a little script which says, Basebox change config, and you say Basebox change config local or Basebox change config remote, and then you give the IP address of the remote controller, and then you have stuff. So it's relatively easy now. We have FRR as systemd, so all of the stuff that we do is working on systemd network D. So you're also configuring your interfaces if you want to have static interfaces via systemd network D. There is an API to it that is a gRPC API. So you would be remotely speaking OpenConfig, and that would be locally translated into the systemd network D configuration. There is ONLP dump support, which you on the box can use to see which SFPs are there, what speed, and so on. So all in all, I would say there's mirror ports, ingress, egress. All in all, I would say it's usable now. there's steps. If we want to build a free and open source router, the first step is, I think, where we are definitely. There's free for download only images. You go to repo.bisdnde/pub/oni, and you can download those ONI images. But that's not really what we want. You actually want to have a package management system. You actually want to build a good distribution. We do have the package management system up, but you actually want more. You want to expose a full SDK for people to build their own applications, to run on the switch. And that's where we are not quite, because here's where we go into, oh, there's the Broadcom SDK, and that's closed source, and so on. But we're on a good way, and if everything goes well, we will at least be able to give the binary of the SDK outside, and Yocto allows us to create an SDK with a binary blob inside, and still give you the rest in open source. So that's where we are with this. Since I've been talking about this thing, people are asking me, so where's your business? That's a very good question that I'm actually not getting in Europe. So the answer one is it's in open source, so we offer support licenses if anyone wants that. And we do custom function development. So like recently a customer asked, I need the mirror port. So I said, yeah, gonna be 2 weeks, and they had it after 2 weeks. So that's fine. And second is, for us, the operating system and the white box switch is commodity. It should be commodity. It should be free anyway, because also we want to use it to build our own applications. We want to build a BMG. We want to build whatever gateways on top of that. I don't want to deal with this actually anymore. We are now members of Stratum. So where do we go with that? Right now, we're speaking OF agent, OFDPA. I think Jim Warner was saying that already 2 years ago. Yeah, we kick out the OF agent and we put in something like a P4 agent, and that would be the straightforward way for us. We still want to keep Basebox D, the Netlink kernel integration, but we're going to replace it with a P4 runtime southbound interface. And if anyone finds that interesting enough, so we'd be willing to contribute everything of that into Stratum. We just have become members a couple of weeks ago, so this is where we go. As we already had the gRPC open config-like interface, I think at least that part we're covered. So on the GNMI, I think that will be a relatively easy fix. Next thing would be to gradually move from OFDPA to P4 runtime. But I think we do have some time for that. I mean, the market out there is still way behind, I think. So I'm not being asked so much for P4 at the moment. All right, so this is where we are. And so the whole idea, there's a lot of links here of documentation, examples, how you would be setting it up, where you can download stuff. That's where we are. I think the whole point is, with this bit of a C++ glue, we were saving us a lot of work and effort in not having to rewrite the entire networking stack, because it's all there in Linux. What's not there in Linux at the moment is MPLS. So if anyone wants to do segment routing in MPLS, just go and use ONOS. It's fine. It can still perform. But by the way, also MPLS is now coming into the kernel, so it won't be long until we will also see that.